Hey guys, it's Mr. Lambert. I'm coming at you with a little review lesson today over rational and irrational numbers and how we go about comparing and graphing rational numbers. So, again, we're going to focus on graphing rational numbers today. Rational numbers. If you didn't get this down in your vocab before, please do so now. A rational number. It's any number. You can even use the number sign, the pound sign, I don't care. Any number that can be shown as a ratio of two integers. Now, I know that sounds really scary. Any number that can be shown as a ratio of two integers. What does that mean? Well, remember, an integer is just any whole number. And a ratio is basically a fraction. So anything that can be shown as a fraction is a rational number. So we have things like, of course, the number 3. 3 is a whole number. It can be shown as 3 over 1. It's a rational number. The number -5. It can be a rational number because it can be shown as -5 over 1. Also, most fractions and decimals are rational numbers. Let's see, 0.75. 0.75, I know off the top of my head that one. That one is the ratio of 75 over 100. Again, remember, all decimals, most decimals at least, are easy to show because you go to the place where the decimal terminates or ends, and you look at what place that is. This is 75 hundredths, so 75 over 100. Easy breezy. As you can see here, fractions, of course, are also rational numbers because they are automatically a ratio of two integers. So those are rational numbers. These will be your examples up here. Non-examples of rational numbers. I'm going to put these in blue. These are really weird things, most of which we haven't got to yet. Square roots of numbers that don't have normal square roots. Like the square root of 2. A square root is when you can divide something by itself. So like the square root of 9. You have to figure out what two things that can multiply by themselves to get to 9. So 3 times 3 is 9, so 3 is the square root of 9. 2 doesn't have a whole number square root. It actually gets into some weird decimals that don't start repeating. That is an irrational number. Also, things like square root of -7. This is an irrational number. You can't multiply two things and get 7. You can throw a negative in front of it. That's cool too. Also, weird decimals like the number pi. The number pi, if you write it out, it doesn't ever repeat. It just keeps going on in this weird string of numbers that keep looking different as it goes. Supercomputers have gone on for literally years and years and years, doing thousands and thousands of places of computation per second, and we still haven't found a repeating pattern in the number for pi. You'll use that later when we get to circles and other things in math and geometry. But these things are examples of things that are not rational numbers. Most of what we've dealt with in math so far in your math career are rational numbers. So how do we order these rational numbers? Well, again, we're just now dealing with decimals, fractions, and whole numbers, be they positive or negative, but you know how to deal with these things. So the first thing when we're going to order some rational numbers, this is what you're going to be doing today. The first thing you need to do is rename your rational numbers so that they all look the same. So in our case down here, I've got a couple of numbers that we're going to work with. So we'll do green for -1/4. Now -1/4, if we look at our other two numbers are decimals. -1/4 doesn't look like a decimal, and that's because it's not as a fraction. However, if I were to divide 1 by 4, I would get the number 0.25. You can check that out on your calculator right now if you'd like to. But 1 divided by 4 is 0.25. And in this case, our number is negative. 3/3500ths right here. I'm going to do him in orange. I'm going to rewrite him just a little bit. I'm going to put my 0 in there so I remember that that's a place that I'm working for. But now I've got him to a reasonable decimal. And we'll deal with this guy. We'll do the same. We'll put a 0 in the front so we keep our place. 0, 0, 2. So 0 and 2 thousandths. All right. So we've got each of our rational numbers as a decimal now. In decimal form is pretty easy because they basically all have the same number of pieces. These will of course be hundredths. These will be thousandths, but we still know what we're dealing with as a decimal. Now they're going to be easy to graph on our number lines. And I'm just going to graph them. I'm going to use the color of marker for the number that we chose up here. So this is 0.002 or 2 thousandths. This guy is going to be way up here, 1/5 of the way to 1/10. So he's not going to be very far at all. He's going to live somewhere around here on our number line. 3/500ths. Again, that's going to be right here, directly in between 3/10 and 4/10. And last but not least, I have -2500ths. And that would be in between my -2 and my -3/10. Right smack dab in the middle. And now, ladies and gentlemen, if we remember what we learned last week and the week before about graphing integers on a number line, non-integers that are rational numbers work the same way. Larger numbers will be further to the right. Smaller numbers will be the furthest to the left. So if I'm going to go from my least to the greatest, or my smallest to my largest number, I'm just going to start right here on my left-hand side. So the first one was -2500ths, so -0.25. My next number would be my next number on my number line. It would be this. It would be 2 1,000ths, 0.002. And last but not least, we would have our largest, or the farthest to the right. We have 0.35 or 35 hundredths. And ladies and gentlemen, that's how you're going to work out graphing rational numbers on a number line. If you have any questions on that, please make sure to contact your teacher because you're going to be doing this today on IXL. First thing you're going to be doing is just graphing single points. So you'll take one number and you'll graph it on the number line. And then later on, you're going to be comparing numbers. You get to use a number line to compare those two numbers. Remember, further to the left is going to be smaller. Further to the right is going to be a larger number. All right, guys and gals, that's all I've got for you today. Try the guided practice questions below, and then on to your IXL. Remember, if you've got any questions, check in with your teacher. Thanks.